Hello and welcome to this first lesson on the atoms, elements, compounds and mixtures topic. We call this C1a at our school, and you are very welcome to join us. We will be really focusing on the way in which we write notes during this topic. So on this first slide, you can see that there are a few links to lots of different YouTube videos that will take you through how to write really good notes. Now, we fully appreciate that different people do notes in different ways, but note taking is such an important skill for scientists. So we really encourage you to take a look at these videos. We'll put the links in the description down the bottom. So this first lesson is on atoms, elements and isotopes, and we really need to thank Twinkl for these resources. They've made them free at the moment, and we have adapted them here for our teaching. So in this first lesson, we're really going to be looking at understanding the structure of the atom, how that links into what elements are and their structure, and also we're going to focus on isotopes as well. Now, the success criteria, we're going to be able to define the terms atom, elements and isotopes, describe the structure of an atom, and then a bit of an extension later on for higher tier is to be able to use the information about isotopes to calculate what we call the relative atomic mass. Now, you will have noticed already that some of the words have been highlighted in different colours. So this is a technique that teachers use, obviously, to highlight the keywords throughout. And it's a technique that I've used in my teaching for a long time to highlight the what we call the purple words, so the keywords. Now, they are specifically the keywords that are in the glossary at the end of the textbook that we use, the AQA chemistry textbook. And I'd really encourage you to get a copy of that glossary so you can learn your keywords. So the keywords can be highlighted in purple. Throughout these slides as well, there is a number of tasks. All tasks are in a red font, so it will say task 1, task 2, task 3, or whatever. And then there's also extension tasks that are set down the bottom, just to get you thinking outside the box. And at the end of each lesson, we're going to briefly summarise, or want you to briefly summarise what you've learnt, maybe using the bottom of the page to write the main points of your notes, or to write a flashcard for the lesson, or try and cram all of the information reduced down into a post-it note. And that would be, really brilliant to summarise what you have done. So what do we know? Here's task number 1. Can you label a diagram of the atom? The key terms are there for you: nucleus, proton, neutron and electron. They're purple words, so they would need defining as well. And the extension task: can you state the charges of the subatomic particles? So off you go. Give yourself a minute or two, see if you can draw that. If you need to pause the video now, this would be a good time to do it. So there's the answer. There's our model of the atom. We've got a nucleus in the middle. The nucleus is this bit just here, okay? It's not something that has been named on this diagram, but the nucleus is right there in the middle, and it is made of the positive protons and the neutral neutrons. The electrons whiz around the outside. They orbit around the outside in what we call shells. So, the atom. Here's some facts. Atoms are neutral. They've got no overall charge because the number of protons and electrons are the same. So if you had 5 positive protons in the nucleus and 5 negative electrons going around the outside in the shells, then the 5 plus and the 5 minus would cancel each other out and you wouldn't have a charge, which is why all atoms are neutral. Now, there are some charged situations. We talk about something called ions later on in the chemistry schemes, but for now we're just concentrating on the atom. Okay, atoms have a radius of 0.1 nanometers. That is tiny, really, really tiny. And so the extension task now is to find out what a nanometer is. Could you express it in standard form in relation to 1 meter? So pause the video, see if you can find out about a nanometer. Okay. A nanometer is 1 times 10 to the power of minus 9 meters. So that is really, really tiny. Okay. We talk about units of measurements in everyday life. We're generally talking about a centimetre or a metre. Now you would get 100 centimetres in a metre. So obviously 1 times 10 to the minus 9 of a metre is really, really tiny. So we've talked about the atom and the structure of an atom, but we also have this word called elements. So elements are made of only one type of atom. Okay, so on the periodic table, we call it the periodic table of the elements, and we have 118 different elements, so they're just different types of atoms, and each one is slightly different because it has a different number of protons in the nucleus. So we represent them with a name on the periodic table and with a symbol as well. Okay, so for example, our carbon just there has the symbol C, and sodium over here has the symbol Na. And the reason that sometimes the letters don't necessarily match the name is because there have been different people across the world that have been instrumental in putting the periodic table and the elements together. So the element name might come from a different language. My favourite one as an example for that is tungsten down here. Tungsten is a metal used in light bulbs. It's used to make the filament in light bulbs. But its symbol is a W, and that becomes from the German word for it, which is Wolfram. There's loads of other common ones as well. Iron is Fe, for example. Gold and silver, which are Au for gold and Ag for silver, and clearly they don't match the gold and the silver name. So it might be worth having a look, see if you could find out some of those. At this point, I would always say it's really good to make sure that you have a copy of the periodic table to hand. You can always search on the internet and find one of those, or get a copy sent to you by your teacher. So, on the periodic table, we can see, for example, here we've got oxygen. Oxygen's great. It's in our atmosphere. 21% of our atmosphere is made of it. And on the periodic table, we have two numbers. We have the number at the bottom, that's called the atomic number. It's also, you might see it quoted on the periodic table as the proton number. And that is because, if you have a look down here, that is because the mass number is the total number. Oh, I've said the mass number there. That's because the atomic number, that bottom number, is the number of protons that the nucleus has. It also happens to be the number of electrons as well. Now, the mass number, which is the number up the top, that is the number of protons and neutrons added together. Okay, so it says down the bottom the mass number is the total number of protons and neutrons in an atom. That's why it's bigger than the atomic number. The atomic number is just the number of protons, but the mass number is the protons and neutrons added together. So here we go. Next task is a quick assessment. These are exam type questions. The answers will be on the next slide. So if you pause it now, and then once you've completed them, you can move on to the next slide. So there we go. Magnesium is in group 2 and period 3 on your periodic table. There's the diagram of it. What is the mass number of a magnesium atom? So you'd go to your periodic table, you'd find magnesium, and the top number, or the larger of the two numbers, is 24. So that would tell you that in the nucleus there's 24 things. So it's made up of a total of 24 protons and neutrons added together. The next question says, what is the charge of a proton? So protons are always positive. Protons are found in the nucleus. Which other subatomic particle is found in the nucleus? Well, we've said this already. The mass number, which is what's in the nucleus, is made up of protons and neutrons. So other than protons, it must be neutrons. Which particle number is always different for atoms of different elements? Well, to be an element, you have to have a different number of protons. So hydrogen would be 1 proton, helium 2 protons, lithium 3 protons, and so on and so on. Right, all of the atoms are neutral. Explain why. Well, that links very specifically to what we did and what we looked at earlier on. An atom has always got the same number of protons as electrons. So positive protons cancel out the negative electrons. So if it had 5 protons, 5 electrons, they would cancel out, so there'd be no charge. Right, another quick task. The first 20 elements. So give yourself a minute, set a timer for a minute, maybe on your phone. See if you can name or give the name of any of the elements in the first 20. So see if you can do that. And now try to write them down. So now that you've tried to memorize the first 20 elements, see if you can write down all 20 or as many as you can now. There you go, here's the first 20. So yeah, we've got hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. The reason the first 20 are quoted here is because at GCSE, in terms of having to know lots of stuff about the elements, we're really interested in the first 20. After the 20th one, we start to creep into the transition metals, which is the bit in the middle of the periodic table, and it all starts to get a little bit complicated then. Okay, isotopes. We've looked at atoms and elements, so elements being different types of atoms. I said earlier about things that might have a charge and might be slightly different. Well, an isotope is different again to this. So you've got your purple word there for isotope. So if you look up the definition now and write that down, that would be good. Look at the mass number of these two. They're 2 carbon isotopes. One says 12,6, the other says 13,6. Now, in order to be carbon, you must have 6 protons, but the mass number here is different. So the number of neutrons must be different. Okay, if we've got a mass number of 12 just there, so there must be 6 neutrons and 6 protons in order to make that 12. But over on the right here, we have got our 6 protons, but we need to get up to 13. Well, 13 take away 6 is 7. So that carbon must have more neutrons. So an isotope has the same atomic number, but a different mass number. Okay. Isotopes are different forms of the same element. They've got the same number of protons, but they have a different number of neutrons. So this just means that they have slightly different properties from each other. Okay, isotopes and relative atomic mass. This is for higher tier students. To calculate the relative atomic mass of an element, the following formula is used. So it's the sum of the isotope abundance times the isotope mass number. So you might be given a sample and it would have a certain percentage of one isotope and a certain percentage of the other. We would take that, or the sum of the abundance times the isotope mass number, and we'd divide it by the sum of the abundance of all of the isotopes. So an average. So if I was trying to look at an average number of something, I would take everything added together that I'm interested in and divide it by the total. Okay, so the total number of them. So here we've got an example where it says chlorine has 2 isotopes. Chlorine 35 has an abundance of 75 and chlorine 37 has an abundance of 25. So on the top we're putting, so if we're looking now at this, on the top we're saying, right, 75%, so the abundance, times the mass of that chlorine, which was 35, and I'm adding that to the 25%, the abundance, times the mass of 37, and then I'm going to divide that by the total number of them to get my average, and the total number was 75 plus the 25 makes 100, and so therefore my relative atomic mass, or the average of all of those isotopes, is 35.5. Now, that was a fairly quick way of having a look at it. It would definitely be worth finding other examples. So yeah, the extension task is there. Do some research, find some other common isotopes and their uses, and it would definitely be worth looking up other examples of using that equation just there. Okay. Task 4 then, a quick assessment. This is to do with what we've just talked about, so the abundance of different isotopes. So can you use the information in that table to try and work out the relative atomic mass of this unknown element Z? Pause the video now and give yourself a couple of minutes. Here we go then. Here's the answer. You were told that you had a relative abundance. So I'm just going to focus on that answer there. The relative abundance was of one isotope was 60%, and that had a mass of 12. So you've times that together. And then the other one had a relative abundance of 40%, and you times that by 14. And then you divided the whole thing by the total number that there were, which was 100. So that's where those numbers have come from. The abundance times the mass, and then added those together for all the different isotopes, and then divided it by the total number, which was 100. So what you get out is 12.8. Now, at this point, you should be thinking, oh, okay, 12.8 seems all right, because you were given one that had a mass of 12 and one that had a mass of 14. So your answer can only be somewhere in between those two. Now, as you had more of the 12, you had 60% of the 12 and only 40% of the 14, then that would mean that your answer should lie closer to 12 than it would to 14. Hence why it's 12.8. Okay? So, we've reached the end of this first lesson. I would make a real point of making sure that you've gone back over your notes, you're really happy with the definitions of all the key words. Create yourself a brief summary of this lesson's notes. Try one of the different techniques I've got listed here. So maybe this first one, write the key points in separate bullet points to reduce the information down, and I've put that in bullet points to make my point. Second one then, how about briefly summarising all the key points onto a post-it and sticking them onto the bottom of your page? Or number 3 over there, oh, look at those, beautiful. Let's get some flashcards. If you don't have any flashcards, just get some paper and cut it up into smaller pieces and create a flashcard that's just got lots of concise information about the lessons. Maybe it's the atomic structure, maybe it's about the first 20 elements, maybe it's about what an isotope is, that kind of thing.